Assalamu alaikum. In this video we are going to analyze the normality of our data set. For this I have the data of 5 variables where operational self-sufficiency is my dependent variable and rest of 4 variables are my independent variables. To check the normality on this data, we first need to import the file onto this data. Select your desired worksheet and click OK. To check the normality of the data, normally researchers take two ways, either to check the normality of your errors that are not explained by your independent variables, or either through dependent variable. It upon the researcher's choice to check the normality of either your errors of the model or the dependent variable of the model. For this we need to firstly process the model of this data variables. For this the command is rect your dependent variable and then select all your independent variable. Here you can see that only 12.95% of the model have been explained by these independent variables. However, the rest of the 80% almost 87% almost, the data is not being explained in this model. For this we need to predict the errors of this model. The command for this is predict e reset, and here you can see the residuals of the model have been generated. You can either check the normality of your errors or your dependent variable. I'll show you from both ways. Firstly, we'll check the normality of the data variable by graphical representation. For this, the method 1 is k-density plots. First, we need to analyze the k-density plot of errors. For this, the command is k-density e normal. And here you can see the graph. From blue lines can be seen that it is not actually normal. That means our errors are not that much normal. Now we'll check it through our dependent variable. For this the command is k-density your dependent variable normal, and here you can also see that the blue line shows that the data of dependent variable is also not normal. Let's move on to another method, another graphical representation, that is p-norm graph. Right, so the command is p-norm and then select the errors, press enter. You can see that if the data points are not on line, that means the data points are not normal. Our errors are not normal for this model. Let's check the normality of dependent variable through this method, and it is also can be seen that it is also not normal as it is not on the line. You can see over here. Let's move on to another method, that is Q-norm graph. For this the command is Q-norm e if you are checking the normality of your errors, and here you can also see that the points are not on line, this line, the straight line, and the data points are scattered. That means these are not these data points are not normal. Let's move on to checking the normality of your dependent variable. The command is Q-norm and select your dependent variable, and again you can see that the data points are not normal as it is not on the line. Let's move on to our next method, that is the histogram method. Right, for this the command is histogram your dependent variable normal, and on the histogram data points, data bars, you can see that a line which is not as much normal because it is more peaked, not a normal curve. You can also check the normality of your errors through this method. You just need to mention histogram e normal, and here you can also see that the data curve is more peaked, not a normal curve. Let's move on to the test method. The first test is Shapiro-Wilk W test. For this the command is swilk e for checking the normality of your errors. You can see that the probability is less than 0.5 and 0.1, actually 0.01, that means 1%. if the you can interpret as if this probability is greater than 5%, then the data is normal. If it is not, then the data is not normal. And according to this test, the probability is less than 1%, less than 5%. That means the data is not normal. You can check the normality of your dependent variable as well. And again, it is not normal as it is less than 5%. Let's move to another test, that is JB test, Jarque-Bera test. For this, the command is JBE. If you haven't installed this command, for this you need to install the JB command. The command is ssc install JB, and your command will be installed. As I have already installed, so there is no need to install it again. Let's process the command, that is JBE, and this is showing that it is not normal as the chi value is in very negative point. Let's check it out for the dependent variable, and again it is in negative points. That means it is not normal. Let's move on to another test, which is Shapiro-Francia W test. For this, the command is sFrancia E. Select, enter, and then you can see that probability is very less than 5%. That means our data is not normal. The hypothesis for all these tests is if the probability is less than 5%, 0.05, then the data is not normal. And if it is greater than 5%, then our data is normal. Now check the normality of your dependent variable through this test. Again, you can see that the probability is very less than 5%, which means our data is not normal. Let's move on to another test, that is Skewness-Kurtosis test. For this, the command is sk-test-e for errors, and here you can again see that the probability is very less than 5%, which means our data is not normal. Data errors are not normal. And let's check for the dependent variable, and again it is showing that the dependent variable is not normal. From all the graphical representations and from all the tests we have performed, you can see that not the errors, either the dependent variable nor the errors are normal in our data set. So we need to transform or change the distribution of these variables. For this, you need to check out our next video. Thank you.